In this video, we are going to learn about Lewis structures, and Lewis structures represent valence electrons. These are the electrons in the outermost energy level, and the reason that we study these in particular is because these are the electrons that are most responsible for the atom's behavior. One thing that you do need to note is that you can have no more than 8. If you're doing a problem and you come up with more than 8, go back and check it because that can't happen. Now, we get valence electrons from our electron configuration. So for sodium, our electron configuration is neon in brackets 3s1. So the 3 is our energy level, and we can see that there's 1 electron in the third energy level. So sodium would have 1 valence electron. Sulfur also has 3 energy levels, but it has 3s and 3p, so we have to add these two together. So 2 and 4 means that sulfur is going to have 6. For manganese, notice that the highest energy level is 4. 3 does fill after, but it's still in a lower energy level. So manganese would have 2. Tin, we've got 5s and 5p, 2 in each. So we have 4 valence electrons there. Barium, highest energy level is 6, so we have 2 there. Now, we know that electron configurations are on the periodic table are common to the columns or the groups. So the alkali metals all have 1. Remember, because they all end in S1. Alkaline earth metals all end in S2, so they have 2. The boron family, this is column 13, they end in S2 and P1, so they have 3. Carbon is S2P2, so they have 4. Nitrogen has 5, which is S2P3. The chalcogens have 6, S2 and P4. Halogens have 7, that's your S2 and P5, and the noble gases have 8, which is S2 and P6. So if we look at our periodic table, we can see that there is a pattern. 1, 2, then we skip the transition metals. These guys have different numbers of valence electrons depending on where their electron's at. They're always in transition, so we can't really predict that too well. Then we come over here to column 13, which is 3, 14 is 4, 15 is 5, then we have 6, 7, and 8. So 1, 2, skip a few, then 3 through 8. Now there is one exception, and that's helium here. Helium is in the first energy level, and it can only have 2 electrons, the 1s2. So even though helium is in this last column, it still only has 2 valence electrons rather than 8. And we'll talk about why it's here. So the rules that you need to remember to write the Lewis structures, or dot diagrams as they're called. Now this is for a single element. You're going to write the symbol for the element and then surround it with the correct number of valence electrons. And what you do is put 1 electron on each side, and then you pair them up. So I just have this on the side to help us remember our pattern. So if we have sodium, okay, sodium is here in the first column, an alkali metal, so it's going to have 1 dot. So we just put 1 there. And it really doesn't matter which side you put it on. Okay, you just have to have 1 dot there. Magnesium, which is here. Okay, it's an alkaline earth metal in the second column. It has 2 dots. So the way we do that is 1, 2, just like that. Phosphorus is over here, column 15. It has 5. So 1, 2, 3, 4, and then we pair with the 5th one. If we have sulfur, which is here, okay, it has 6. So 1, 2, 3, 4, 5, and 6, just like that. So if you pay attention to the pattern and know how to figure out number of valence electrons, then remember that you put 1 on each side before you pair them. You'll always be able to do these Lewis structures for single elements.